Nick's an IT professional specializing in blockchain, distributed ledger technologies, and financial services, and has been working, designing, and developing solutions that use blockchain technology for a few years. Nick's a member of FinTech Australia and co-leads its blockchain subcommittee, which is engaged in policy and standard setting for emerging blockchain technologies. He frequently speaks at blockchain events in universities, as well as helping run the Sydney Ethereum meetup. Please welcome Nick Addison.
Good. Okay, so yeah, this is a bit of like just-in-time presenting. So I've just repurposed a slide deck, but I'm going to emphasise a few things which I think is more relevant to the legal side, because we've sort of got this blockchain legal mixing, if you like. Now maybe just to help, I've had kids' duties this morning, so I don't know whether anyone's done this before, but I'm interested to know where we sit with lawyers or people studying law, or a few lawyers who are willing to admit, a few hiding. And what about like technology people? Oh, good. Okay, so we've got half. And who's neither? I'm just here to help other people. Awesome. So I want to focus on the enablers of blockchain. So although this has got, I don't want to go through explaining what a blockchain is. I more want to focus on what can you do with a blockchain, and particularly with a legal bent on it. So that way you can sort of start thinking about, well, how can I take and use such technology? Now, everyone has a different definition of blockchain. I've got mine. I won't spend too long on this. It's rather wordy. What's wordy for me anyway, being a tech guy. So a peer-to-peer, append-only data store that uses consensus to synchronise cryptographically secured data. So I'll break this down. Peer-to-peer, most people know what a peer-to-peer system, like different nodes or servers or computers, whatever you want to call them, distributed all over the world, talking to each other. The only thing I'd emphasise on this one is there's no central control. So for example, when Napster had its legal action against it, there was a central computer that could basically shut that down, cut the head off the snake, the whole thing falls over. A lot of them, particularly the public blockchains, so things like Bitcoin, Ethereum and others, take out half the nodes, the thing's going to keep running. Take out 95%, it's still going to keep running. That's sort of an important point in that it's just got to run. As long as there's the internet, and the internet's designed to handle nuclear war, it's going to be there. Append only is quite key. So in a blockchain world, and I realise people sitting over there might get to see me. Maybe I'll move over here. So in a blockchain world, you can basically add transactions in, and think of it as like layers of rock, sedimentary rock. You can't go back and change, you can't go back and delete a transaction, you can't go and update the data on a transaction. It just gets baked in, and the more layers you add on top of it, the harder it is to, it's almost impossible to go back and change. So append only. Now consensus, I normally spend a bit of time talking about different consensus mechanisms. Basically this is about how do you get to agree, you synchronise this data. So this whole, all these servers running all over the world, how do you get them to agree on which transactions are valid and the state of the system? I'm going to skip over that because I don't think it's that important. And normally I skip over the cryptographically secure bit, but I think this is quite important from a legal aspect. So I'm going to do more time than what I normally do on cryptography. Now, has anyone actually studied a court case or been to a court case where there's been a cryptographic proof involved? Someone where they've actually... No one? I was hoping there was someone here so I could or we could make it a bit more interactive. Okay, so there's two things on cryptography. One is this concept of a hash. So if I take a picture of you lovely people sitting here, I can take a hash, which basically run it through an algorithm, and I'll end up with a string of data, which is basically a hash of that picture. Or it could be a legal document, or it could be, or it could be something bigger, like it could be like a whole movie. But any piece of data, basically, you can take a hash of it, and you end up with this piece of data. So as long as you've got the original, and as long as you know the algorithm, the hashing algorithm used, you can basically prove that hash matches that original document. Now this has been around for a long time in computing, but and what's also interesting about it is if you just if I took that picture and just changed one pixel by just one little colour gradient, the output is completely scrambled and unrecognisable. So that's the hash bit. The next bit, which is very important in the blockchain world, is this concept of cryptographically signing something. And this is where we start getting into public and private keys. So effectively, if I have a private key, it's like think of it as like a big long password. And the way, and I can generate a public key which I can share with everyone. So on this private key, I can grab that, I took that picture, I've taken a hash, then I can go and sign that hashed data. It could be any bit of data, but let's just say it was the hash of that picture. It's going to produce out a signature, which is another piece of data. But what's interesting about this one is I can give you my public key and I can give you the thing which was being hashed, and then you can basically prove that I signed it. So think of it as it's like a cryptographic proof, which I think in a law point of view, when you talk about proof, and I guess a lot of law is about proving evidence against things, it becomes quite powerful. So just to go through it again, so if I have a bit of data and I cryptographically sign it, I'm going to end up with a signature, which is just another piece of data. But if I can take that piece of data, that signature, match it up to what was originally signed, I can get my public key. But I don't, so you've got my public key, you've got the data which was signed, you don't have my private key. So I don't have to reveal my private key. And as long as you can confirm that I control that private key, then you confirm that I actually signed that document or signed that piece of data. And that is used quite a lot, pretty much in blockchain, this concept of signing things. And then we'll go through and enables of what you could do that in a blockchain sense. So we'll come back to those ones. So any questions on that so far? No? Good. Maybe just a couple of key concepts on sort of blockchain. So one is so I think of all those little dots. I talked about like a peer-to-peer network on that previous slide. Think of all those dots scattered all over the world, and the big cloud being conceptually the blockchain. The way to get something into the blockchain in terms of putting a transaction in or changing state within a blockchain is through a transaction. And effectively that is someone using their private key cryptographically signs some data, a transaction, and publishes it out into the blockchain, which then goes through some mining or a consensus mechanism, but we'll just ignore for now. The key point is that someone had to sign a transaction and publish that out. So it has to get, people have to verify the signature of the transaction, verify various bits of data with it. So it's transaction in, and once you're inside, so something like Ethereum, which has this concept of smart contract, which is basically like a computer running inside it, it can't get anything outside. So one of the key, I guess, design pieces of this is that every time you run that program at that particular point in the chain, so you can play back basically all the programs up to a point in time, they have to have the same output. They have to come to the same, agree on where everything is at. So it means you can't actually go out and get the stock price, or go and get the weather event, or go and get external data inside those programs running in there. The only way to get data from the outside is through a transaction coming in. So you can sign a transaction saying, well, here's the stock price as of today. And then the contract can go and use that, but the data has to be signed to come in, and it can't go out and seek it. Then this concept of an event, which is basically pushing data back out. So you can watch for events, but the key one there is transactions. I'm going to skip over that and get into... So there's a number of enables. I've swapped the slides around. So there's, I think there's 8 all up. So digital identity. Now I talked before about this private key. So almost that public key I talked about, which is derived from that private key, is what I call your blockchain identity. So that is, all it is you've got your big long password, which is what, 40 characters long if you turn it into like a hexadecimal format. That is effectively controls your identity. But obviously, in the real world, we're not known as a particular key. So the challenge in the blockchain world is how do you tie an individual, a corporation, an organisation, whoever, to that particular private key. And I guess before I jump into that, this concept of cryptography and signing things has been around for a long time, particularly in the financial industry. So I've done a lot of work in payments and trading systems. And just sort of going off a bit of a tangent here, but if I want to send let's just say I want to send a payment to someone, I'll get the data of here's the instructions for the payment, here's who I want to pay, here's the amount, here's where it's coming from, and then using a private key, and financial institutions are used to managing these things, they can sign that data and send it to their corresponding bank, who receives it. They know they've already shared earlier the public key, so then they can say, okay, I've received this piece of data, I've received this instruction, and I can, using the signature which was passed in that instruction, verify against the data which they sent me that it must have come from the counterparty. So there was no one in the middle on the internet who sort of got it and said, well, we're not sending 1 million, we're sending 10 million. So it protects against what they call man in the middle. The challenge, of course, is, well, how do you know that they've got control of that private key? So in the blockchain world, a very simple technique is you can construct a message for them to sign. You can say, here's a random message, or even if it's just like sign this message, please, like it's a known message. Give it to them, and you give it to them in a way which only they have access to. So it might be through a secure web channel, or so they've come through some sort of authenticated way, or maybe it's in person, whatever it is. They sign it with their private key, so you don't actually see their private key. And then they give you the signature and the message you gave them, and then basically you can verify, okay, that person or that entity controls that private key. Therefore, any future messages signed by them, as long as they haven't been hacked and they've lost their key, must have come from them. Which is quite important in the legal side of things, this concept of non-repudiation. So in the payments world, if they send an instruction to do a payment, the counterparty can't come back and say, oh, I never sent that, or I sent the wrong amount. And it'd be interesting to actually look up and see whether, on a legal point, of whether someone's actually gone to a judge and said, well, we've SHA-256 signed this, therefore it must be them, how that actually went down. But I'd imagine as we get, particularly in the blockchain world, as we get more and more down that path, this concept of cryptographically signing things, and certainly a lot of the legal base, there must already be established practices on that. So identity, so it's mixing blockchain identity, which is really just a private key, it's a private-public key pair, and then either trying to prove that identity is attached to it, or it could be the other way around. You could, once you've established your identity on there, you could have other people come in and socially attest to you or things you've done. So might have it's not called the RT anymore, what are they called now? Services New South Wales, or whatever they're called. I've lost track. So they might sign something saying, yes, you have a driver's license, or yes, your date of birth is a particular point, or it might be UTS, you've graduated, they sign that yes, you are now a qualified lawyer, or you've got a bachelor degree, or whatever it is. And all this is sort of premised on people having these keys which they can control and sign it, and then you can go back and prove that, okay, they've actually signed it. So take the degree example. It's pretty easy to fake up a degree. I mean, do employers even check these days? Oh, you've got a degree. and I think some people are actually doing this, where basically you have the educational institution, so the university, signs it, and then a third party can go, okay, here's the degree, here's the signature, yep, I can validate that it's from the university. So that's the identity piece. I'm going to skip to, because it's sort of related, provenance and tracking. So we've had, and yeah, apologies for the air conditioning, it's getting hot. So we've had these cryptographic proofs for quite a while, but how does blockchain add value to this? So one thing which is sort of missing in that, let's take that payment instruction example. There's no point in time with that instruction. So if you go and sign that instruction, you can go back later and sign a different instruction and say, well, no, I actually sent this one here. So how can you go into a, if you had to go into a court and prove that at that point in time, that particular piece of data was signed by that person. And this is where blockchain comes in. So effectively, I talked about those layers of rock. You can effectively take a piece of data, put it in the blockchain, and therefore it's almost like a snapshot in time. Like in other ways, I described, I had my big long definition of a blockchain earlier, but really it's just a series of cryptographic proofs. So if you get that data using that transaction we had earlier, so if you bundle up a bit of data in here, which might be a hash of the picture, put it in here, and assume it gets mined and puts into the blockchain, it's stuck there in that point of time. So that particular block number, that data is in there and it can't be changed. So I think that is one of the big sort of changes or one of the big enablers in the blockchain world. It's like proving something existed at a point in time. So I think that from a legal point of view, that opens up quite a lot. I'm no lawyer, but whether that's pictures of something, signed documents, evidence of something, could be maintenance schedules, aircraft, whatever it is. So it's putting these proofs in the blockchain. So another use case, I spent last year working for an agriculture company, and we were doing quite a bit of work on trying to prove that particular commodities came from a particular area, and the company I work for now has got a similar thing. So this is sort of building on some of those enablers we talked about in the blockchain. So this concept of signing something and an identity and putting it into this point in time. So a lot of this is about, particularly in Australia, well, it's not limited to Australia, but Australia is trying to prove that their agricultural commodities, whether it be some sort of grain, some fish, oranges, whatever, has come from a particular region, or it is even just from Australia generally. So then it comes back into this cryptographic proofs again. So basically you could have different people, different entities, basically attesting to something at a particular point in time. So you might have the farmer who signs something saying, yes, this was organically grown. You might have the handler who signs something and says, yes, I processed so much of the organics through my processor before I started packaging it, therefore it can't be contaminated. Could be inspectors signing off that, yes, I've looked at the practices of this business and they comply with certain things. So it's these different people or things. It could be IoT pieces here, where it could be cameras measuring quality or sensors measuring quality, whatever it is. Grabbing a piece of data, or if you, I guess, on a more legal term, a bit of evidence, signing that bit of evidence and putting it in the blockchain, so it's basically frozen in a point of time. So then off the back of that becomes a whole heap of analytics and stuff, but capturing that data, so you've got you've got a number of things at play there. You've got this immutability of the blockchain and storing something at a point in time. You've got this identity piece of someone signing something. And then off the back of that, you need to try and piece all this stuff together. And you still got to have to go and prove that the blockchain, you still, all these people could go and collude together and say, something was, these prawns were, farmed out of northern Queensland, but in fact they came from somewhere else. Like, all you can do is really take the evidence, and at least you know that the evidence put in there at that point in time hasn't been tampered with. I will probably, here we go for time, okay. Do we want, I can finish up at 3, or I can keep going. Well, maybe I'll do a few more, and then maybe we'll open up to some questions. Asset tokenisation. So Pip and I actually did a talk on this almost 2 years ago now, which feels like a lifetime ago. But pretty much the early use case in a lot of blockchain stuff, apart from the provenance piece, is tokenising something of value and putting in the blockchain. So particularly with things like Ethereum, where there's got this concept of tokens. I don't know whether you've participated in any initial coin offerings, but effectively they're tokenising all sorts of things of value. I'm doing work at the moment, tokenising cash, and I have been working on that for quite a while. So some overseas stuff, or even tokenising the Australian dollar, for example. But you can tokenise all sorts of stuff. So Pip and I did a talk almost 2 years ago of tokenising advertising slots. So think of a digital sign, basically break it up into time slots, and then each token represents a particular time slot. So basically you could generate tokens out into the future and then sell them, basically. So an advertiser could come and buy them, say, well, I want the slots just before Christmas. But then you get closer and maybe their product's been pulled or whatever, they can go and transfer that ownership, basically sell it to other people. There's people tokenising sort of traditional financial assets, people's time, the rights to some services. So the utility token's a common one. So basically they will say, I've got some service I want to sell you, but rather than you pay for it in the future, I'm basically going to sell all these tokens, these rights to this service up front. People can either buy it and then sell it to other people later, but the idea is that you've created this sort of scarce resource. People want to use your service in the future, therefore they'll buy these tokens, or people in the future are going to buy it off the people who are holding it now for things in the future. So asset tokenisation is a pretty common one. Where it gets interesting is when you start getting into custody and escrow. So payments, so I do a lot of stuff in the payments industry, and particularly in Australia it's a bit of a hard sell talking about blockchain and payments because we've just put in the new payments platform. Not all the banks have got it yet, but the question is, well, why can't, you can just do that via NPP? Like, why do you need a blockchain? In fact, blockchain's even slower and more expensive. From a retail perspective, I can send you a payment. You can get it now on a weekend within a minute, and it doesn't cost you anything. But you can do things like escrow. So take that payment example. Say we're sending a payment from one bank to another. Where's those funds sit? Well, it's in this limbo. So effectively, you can escrow it into a contract until the other party signs off and says, yes, I've given it to the customer, whether that's crediting into their bank account, or if you're working in other regions, the unbanked, I've actually given them the cash, sign it off, and therefore that releases the funds. Or they reject it and say, no, the bank account is incorrect, or no, the person hasn't come to claim it, or maybe there's a timeout, so you can basically automate that into the smart contract, releases the funds back to the sender. So that sort of escrow feature is not something which exists in the existing payment rail. And the ability to be able to combine both that asset tokenisation, so take some work I did last year working with a multinational bank, was we were tokenising agricultural commodity, and we're tokenising cash, and then we're doing delivery versus value. We're doing an atomic swap of those two assets. So basically you had a grower who owned the grain, selling to a buyer or a trader it was financed from the bank, and in one transaction, we could transfer the ownership of the grain through to the bank, because they have to sit in their balance sheet, and the cash, the money which is borrowed from the person who's buying it, back through the buyer back to the seller, the producer. In fact, we could even do it so we could have multiple beneficiaries on that transaction. So, the payment doesn't usually just go to the grower. There's other people who've processed it, etc., in that payment. So, in one atomic transaction, it's either both parties are happy with the deal and they've signed off, and you present it into the blockchain, and it completely swaps, or it doesn't. So that delivery versus value, that atomic swap capabilities, really gets interesting. So yeah, just tokenising something and moving around is interesting, but then being able to program conditions onto it is where I get a lot more excited. I might open up to questions here. That's probably a good point. Yeah.
We've been living with civil law contracts for quite some time now, and using them most of our lives. Now we're presented with the concept of a smart contract.
Yep.
How is a smart contract similar to a civil law contract, and how is it different?
Well, I don't know what a civil law contract is, so I won't be able to answer that question. But I can say a smart contract is really just a program. So, calling them smart contracts maybe been a little bit dangerous. And this concept of automation, we have automation all the time, which needs to comply with the laws. There's businesses who are running websites which automatically processes people's transactions. There's all sorts of automated servicing, particularly in the finance industry. So I don't think it's such a new concept of a computer program doing some sort of automated action. I think it gets a little bit more interesting when you start pushing the boundaries, I guess, into the more libertarian side of the blockchain piece, where it's the code is law, but I'm not that. So sorry, I can't. Someone else might be answering that question.
On the contract side, there's a presentation going around somewhere saying smart contracts and smart contracts. Fundamental basis without better price side is that contracts work by the assumption that there's already a standing contract as opposed to the underlying code. So there's always multiple codes running around saying this will coordinate the world. They don't have the fact that you actually have to sign up to it, or it means nothing. You can't force it onto someone else to get them signed up to it. It just doesn't work. It won't be enforceable. Where it comes into play usually, this is where it's meant to actually affect financial services, is we have a lot of payment systems internationally where you can say our contract with the counterparty, rather than us having to fax each other stuff, we use a smart contract. The smart contract will just be the facility of service.
And maybe just I'll finish up. Maybe one more enabler, I guess. So I'm also doing some work on the decentralized exchanges. So this is take that atomic swap concept. So you've got one asset for the other, and you want to swap it. What you can do is both parties sign the terms of that exchange. Basically, I'll swap you, X number of these tokens for Y number of these tokens, which could represent cash, and let's just say it's grain. So basically, they both sign that, and then they basically permission a smart contract to be able to transfer those tokens, and they present into that transaction the signature that they've signed off on the terms of the contract, and then the contract will execute those terms. And that's pretty powerful. In fact, you don't even need the two participants in that transaction to sign the original blockchain transaction. And if anyone wants to go further into tomorrow, I'll be hanging around tomorrow. I can take into more details exactly how that works.
Any other questions? Yep, we got one more in the front here. Are you guys warm enough? I keep turning this up, and I don't know how you see this supposed to be cold.
Firstly, thank you for your talk. Now, I'm still trying to wrap my head around this because it is quite recent, but what are your opinions of hashgraph technology? Do you think it's a viable alternative to blockchain?
So I work for a company called Consensus, which is they're based on Ethereum technology. So I'm in the Ethereum bubble at the moment. But I believe it's quite good. I haven't actually spent any time looking at it. But ultimately, from my limited understanding, it's a consensus technology. So there's many. When I talk about that definition, I just skipped over consensus. That's Hashgraph is one of those. There's others. There's Tendermint, there's Raft, there's a whole stack of them. I'm no expert on Hashgraph, but I believe it's just a consensus mechanism. So, things like a virtual machine and things like that doesn't exist. But yeah, I'd be very interested if you could plug it into something like the Ethereum virtual machine.
Yeah, the thing is,
Right. Okay. Cool. All right.
All right, well, thank you very much. Let's thank everyone.